What if I told you that Chrysler's most feared street engines weren't hiding in Chargers or Challengers, but in pickup trucks and motorhomes? Picture this. It's 1974, and while insurance companies are strangling muscle cars with astronomical premiums, and the EPA is choking them with emissions regulations, Mopar engineers are quietly building some of their most powerful engines ever. Not for the street, not for the strip, for hauling boats and pulling travel trailers. These weren't detuned smog motors either. We're talking about engines with forged steel cranks, beefy connecting rods, and cylinder heads that flowed better than anything in the muscle car catalog. All it took was one camshaft swap to transform these overlooked workhorses into legitimate street killers that could embarrass big block Corvettes and 455 Pontiacs. The summer of 1978, a guy named Mike Brennan rolled up to Atco Raceway in New Jersey, driving what looked like a beat-up Dodge D150 pickup. The regulars laughed. Here comes another farm truck trying to race, they thought. Mike popped the hood. Underneath sat what appeared to be a standard 440 truck engine, complete with cast-iron exhaust manifolds and a two-barrel carburetor. The laughter got louder. Then Mike made his first pass. The truck ran 1280 at 108 miles per hour. The laughter stopped. What nobody knew was that Mike had discovered something Chrysler never advertised. The 440 engines built for trucks and motorhomes between 1972 and 1978 were actually stronger than the legendary 440 six-pack engines that powered the most feared muscle cars of the previous decade. Now, and this is the story of how Mopar's heavy-duty truck engines became the most unlikely performance bargains in automotive history, and how a simple camshaft swap could unleash power that Chrysler's lawyers never wanted you to know about to learn. To understand why these truck engines were so special, we need to travel back to 1972. The muscle car era was dying. Compression ratios were dropping faster than a lead balloon. The 1970 Plymouth Cuda 440 six-pack made 390 horsepower with 10.5.1 compression. By 1972, that same basic engine in passenger cars was down to 8.2.1 compression and 280 horsepower. Insurance companies were charging young drivers more for coverage than the cars cost to buy. Gas prices were climbing. The party was over. But here's where it gets interesting. Chrysler's truck division had a different problem. Their heavy-duty pickups and motorhomes needed to haul massive loads up steep grades in 120-degree desert heat without braking. Emissions regulations for trucks were less strict than passenger cars. Insurance companies didn't care what engine was in your work truck, so while the muscle car guys were getting neutered engines, the truck division was getting the good stuff. The foundation was Chrysler's RB Series big block, specifically the 440 cubic inch variant. In passenger cars, this engine was being strangled with low compression and mild camshafts to meet emission standards. But the truck version? That was a completely different animal. These engines came with forged steel crankshafts rated for 7,000 RPM. The passenger car 440s after 1971? Cast iron cranks that would scatter like a grenade if you pushed them past 5,500. The truck engines got heavy-duty connecting rods with larger bolts. The passenger cars got standard rods. The truck engines received special heavy-duty main bearing caps. The cars didn't. Even more incredible, the cylinder heads on these truck motors were the exact same castings used on the high-performance 440 six-pack and 440 Magnum engines from the muscle car glory days. Part number 406-452. The legendary 452 heads with 2.08-inch intake valves and ports that could flow 240 cubic feet per minute at 500-inch lift. And Chrysler wasn't advertising any of this. In fact, they were actively downplaying these engines. The 1975 Dodge truck brochure listed the 443 heavy-duty engine at just 235 horsepower. That number was complete fiction, a defensive move against insurance companies and regulatory bodies. The real power? Independent dyno testing in the 1990s revealed these truck engines were actually making around 310 horsepower right out of the box, with two-barrel carburetors and exhaust manifolds that looked like they were designed by someone who hated airflow. And in the Ford 43 designation was Chrysler's internal code for these special engines. The M3Es indicated the heavy-duty specification. If you found a 441, that was the standard-duty passenger car engine with a cast crank. The 442 was a police interceptor spec with some heavy-duty components. But the 443, that was the full boat performance build disguised as a truck motor. And the camshaft was the only thing holding these engines back. Chrysler installed a tiny cam with just 4 10-inch lift and 2 44 degrees of duration at 50-inch lift. This was smaller than what they put in station wagons. The reasoning was simple. Trucks needed low-end torque, not high RPM horsepower. The cam was designed to make maximum torque at 2,400 RPM, perfect for pulling a 10,000-pound trailer up a mountain pass. But that conservative cam was choking an engine that had the bones to be a street terror. Enter the hot rodders, who figured out the secret. The math was beautiful in its simplicity. A junkyard 443 truck engine cost about $400 in 1980. A performance camshaft from Crane, Comp, or Iski ran another $200. For $600 total, you had the foundation for a legitimate 500 horsepower street engine. Compare that to building a 446-pack from scratch, which would cost you $3,000 just for the short block. The first guys to crack the code were bracket racers looking for consistent, reliable power on a budget. Word spread through bench racing sessions and classified ads in the back of Hot Rod magazine. "I look for motorhome 440s" became the whispered advice at swap meets. By 1982, savvy engine builders were pulling these motors out of wrecked Winnebagos and Dodge Sportsman vans faster than Chrysler could build them. But what really made these engines special wasn't just the bottom end, it was the complete package. The intake manifolds on these truck engines were actually high-rise designs that provided excellent airflow distribution. They were painted orange and looked industrial, so everyone assumed they were junk. Wrong. Flow bench testing showed these intakes were only 10% down from an Edelbrock Performer RPM, and they came free with the engine. The pistons were another surprise. While passenger car 440s got cast aluminum pistons, many of the truck engines received forged units from TRW. These weren't high-compression racing pistons, sitting at just 8-point rope 1, but they were nearly indestructible. You could spray a 150 shot of nitrous at them all day long, and they'd ask for more. So what was actually happening when someone swapped the cam? Let me paint you a technical picture that'll make your head spin. The stock truck cam was designed with what engineers call Archast early intake closing, DIC. The intake valve would slam shut at just 34 degrees after bottom dead center. This was great for building cylinder pressure at low RPM, but murdered power potential above 4,000 RPM. A typical street performance cam would close the intake valve at 60 degrees ABDC, allowing the engine to keep filling the cylinders at higher engine speeds. Here's where the magic happened. Those 452-cylinder heads could flow enough air to support 600 horsepower, but the stock cam was only using about 40% of that potential. Drop in a cam with 500-inch lift and 280 degrees duration, and suddenly you're using 75% of the head's capability. The engine would transform from a stump-pulling torque monster into something that would spin to 6,500 RPM and make power the whole way there. The most popular cam swap was the Mopar Performance Purple Shaft P44527885, better known as the R509 cam, for its 509-inch lift. This was the same camshaft Chrysler installed in the 1969-1970 446-pack Super B and Roadrunner. With this cam, proper valve springs, and nothing else, a truck 440 would gain 120 horsepower. We're talking about going from 310 to 430 horsepower with a Saturday afternoon's worth of work. Torque numbers were even more impressive. Stock, these engines made about 480 lb-ft at 2,400 rpm. With the cam swap and a proper tune, they'd make 510 lb-ft at 3,600 rpm. That might not sound like a huge gain, but moving the torque peak 1,200 rpm higher completely changed the engine's character. Instead of running out of breath at 4,500 rpm, it would pull like a freight train to 6,000. The transmission situation made things even better. Most of these truck engines came backed by Chrysler's indestructible 727 TorqueFlite automatic. This 3-speed unit was virtually bulletproof up to 600 horsepower with nothing more than a good fluid and filter change. The truck versions even came with lower first gear ratios, 2.74.1, instead of the passenger car's 2.45.1, which meant better launches at the drag strip. And real-world results started showing up at drag strips across America. In 1983, a guy named Tom Nelson built what looked like a stock 1975 Dodge pickup, but ran consistent 11.90s at 114 miles per hour using nothing but a junkyard 443, the 509 cam, headers, and a 750 Holley carburetor. Total investment, including the truck, under $3,000. That same performance from a restored 446-pack CUDA would have cost $15,000, and the motorhome engines were even better than the pickup truck versions. Winnebago and other RV manufacturers special ordered their 440s with even beefier components because motorhome duty was considered more severe than truck duty. These engines routinely ran at wide-open throttle for hours, climbing mountain passes while pulling maximum gross weight. Chrysler gave them forged pistons, shot-peened connecting rods, and nitrided crankshafts. Some even got 4-bolt main bearing caps, though Chrysler never officially acknowledged this. And finding these engines became an art form. You had to know what to look for. The engine ID pad on the driver's side of the block would have specific codes. HEN meant 1974, Versfass was 1975, and so on. After that would be 440, followed by a dash and a number. If you saw 443, 440 HP, or 440 HC, you'd hit the jackpot. The date code would tell you the exact day it was built. Engines built between May and September were usually destined for motorhomes, as RV manufacturers did their heavy building in summer for the next model year. The cylinder heads required careful inspection. Not all truck 440s got the good 452 heads. Some got 902 heads with smaller valves. And after 1976, many got the dreaded 513 heads with hardened valve seats but restrictive ports. You had to pull a valve cover and check the casting number on the head itself. If you saw 406 452 cast into the head, you'd struck gold and an N1. Overlooked detail was the harmonic balancer. Truck engines got a massive 8-inch diameter balancer that weighed 14 pounds. Passenger car engines got a 7-inch unit that weighed 8 pounds. That extra rotating mass hurt acceleration, but it also meant the bottom end would stay together at high RPM. Many racers would swap to a lighter balancer for better throttle response, not realizing they were giving up durability. The oiling system on these engines was another hidden advantage. Truck 440s got a high-volume oil pump as standard equipment, part number 383740. This pump moved 25% more oil than the standard pump. They also got a deeper oil pan with better baffling to prevent oil starvation during hard acceleration. The pickup tube was welded to the pump instead of pressed in, eliminating a common failure point in racing applications. But here's the kicker that nobody talks about. The truck engines got special valve springs designed to handle the heat and continuous high-load operation. These weren't high-performance springs in the traditional sense. They wouldn't handle a 600-inch lift cam, but they were perfect for mild street cams up to 520-inch lift. They'd last 100,000 miles without losing tension, something the muscle car springs couldn't claim. And the connecting rods deserve special mention. While they looked identical to passenger car rods, the truck units were manufactured differently. They went through a process called Zhou's nutating, where the rod was twisted back and forth during heat treatment to align the grain structure. This made them 30% stronger without adding weight. Chrysler's part number was the same, 2406770, but truck rods had an Auto HPs stamped near the big end. And then performance builders started getting creative with these engines. Instead of just swapping cams, they'd mix and match components from different years and applications. The ultimate combination was a 1975 motorhome short block with its forged internals, topped with 1967 9x15 closed chamber heads from a 440 Magnum. This pushed compression to 9.8.1 without any machine work. Add the right cam, and you'd have 500 streetable horsepower. Chansin, the intake manifold situation got interesting too. While the stock truck intake was decent, swapping to an aluminum intake would drop 40 pounds off the front of the vehicle and improve weight distribution. But smart builders discovered the stock intake could be modified for serious power. By carefully grinding the plenum divider and port matching the runners, you could get 90% of an aftermarket intake's performance for $0. Ignition timing became crucial with these combinations. The stock truck distributor was designed for maximum advance at low RPM, exactly opposite of what you wanted for performance. But Chrysler's own direct connection catalog had the solution, Kit P3690428, which included springs and weights to recurve any Mopar distributor for street performance. $20 and 30 minutes of work would transform the ignition curve. The carburetor situation was hilarious. These engines came with either a Carter BBD 2-barrel or a Holley 2280 2-barrel, both rated at about 350 CFM. That's like breathing through a straw for a 440-inch engine. Bolting on a used 750 CFM Holley from a swap meet would literally double the airflow capacity. The engine would gain 40 horsepower just from being able to breathe. And then headers were another easy win. The stock exhaust manifolds were so restrictive they actually created 8 psi of back pressure at 5,000 RPM. That's like having a cork in your exhaust pipe. A set of cheap headers would drop exhaust back pressure to under 2 psi and free up another 35 horsepower. Combined with the carburetor swap, you're looking at 75 horsepower for under $300 in used parts. In real-world street racing stories started becoming legendary. In Detroit, a guy running a primer gray 1976 Dodge pickup was cleaning house against big block Camaros and Pontiacs. His secret? A motorhome 440 with nothing but a cam, carb, and headers. He'd pull up to a light looking like he was heading to a construction site, then leave $1,000 paint jobs in his dust. The truck ran 1320s at 104 miles per hour on street tires. Nachman, the insurance companies never caught on. As far as they were concerned, you were driving a work truck with a 2-barrel Ford 40. Your premium was based on a vehicle that supposedly made 235 horsepower. Meanwhile, you're actually packing 450 horses under the hood. It was the perfect sleeper, hidden in plain sight. Ona and Chrysler's engineers knew exactly what they'd created. Internal documentation from the period shows they tested these engines at power levels far exceeding published ratings. A leaked dyno sheet from 1974 shows a 443 making 385 horsepower with nothing but a 4-barrel carburetor and headers. But publicly, they maintained the fiction that these were just truck motors. The EPA actually helped keep the secret. Their testing procedures for trucks focused on emissions at low RPM and steady-state cruising. They never tested what happened when you mashed the throttle at 4,000 RPM. As long as the engines passed the required tests, nobody asked questions about their real capability. And by 1985, the word was fully out. Mopar Performance actually started selling complete 443 crate engines, acknowledging what hot rodders had known for years. But by then, the supply of junkyard engines was drying up. Guys were pulling them out of running trucks and motorhomes, not just wrecks. Prices climbed from $400 to $1,200 for a good core engine. The legacy of these engines goes beyond just cheap horsepower. They proved that the death of the muscle car era didn't mean the death of performance. It just went underground, hiding in unexpected places. While everyone was mourning the loss of high-compression big blocks, Chrysler was quietly building some of their strongest engines ever, just not for the applications anyone expected. The technical lessons learned from these engines influenced a generation of engine builders. The importance of camshaft selection became crystal clear. Here was an engine that could gain 40% more power from a simple cam swap. It showed that the OEMs were leaving massive amounts of performance on the table for emissions and durability reasons. Entrenched and modern engine builders still seek out these blocks. Even today, a 443 block is worth $2,000 as a core for building a serious stroker motor. Bore it .030 over, stuff in a 4.15-inch stroke crank, and you've got 493 cubic inches. With modern cylinder heads and cam technology, 700 naturally aspirated horsepower is routine. But the real beauty of the truck 440 story isn't about ultimate power. It's about accessibility. Here was world-class performance available to anyone willing to get their hands dirty. You didn't need a trust fund or a machine shop. You needed a junkyard, a cam, and a weekend. Democratic horsepower at its finest. The story takes an interesting turn in the emissions testing labs. When the EPA would test these trucks, they'd run them on dynos that simulated typical truck driving, low RPM, high load, steady throttle. What they never tested was what happened at 5,500 RPM with the secondaries on a 4-barrel wide open. The engines would pass every required test while hiding capability that would have horrified regulators. When some of the wildest builds came from combining truck bottom ends with marine components. Chrysler also built 440s for boats, and these got even wilder parts than the truck engines. Marine 440s got steel-backed bearings, chrome moly push rods, and sodium-filled exhaust valves. Find a set of marine heads at a boat salvage yard, bolt them onto a truck short block, and you had an engine that would survive anything. Motors. The cylinder wall thickness on these blocks was another hidden treasure. Passenger car 440s could safely be bored .030 over. The truck blocks, with their thicker cylinder walls for heavy-duty cooling, could go .060 over without problems. That extra bore size was worth another 8 cubic inches, taking you to 448 cubes. Small gains, but they added up. The evolution of knowledge about these engines paralleled the growth of the information age. In 1975, you learned about them through bench racing. By 1985, magazines were publishing articles. By 1995, early internet forums were sharing casting numbers and dyno sheets. Today, there's more information available about these engines than Chrysler ever published when they were new, or some. The human side of this story is just as compelling. Imagine being a young guy in 1980 with champagne tastes and a beer budget. Your friends are driving 6-cylinder Novas and Dusters. You scrape together $400, buy a wrecked motorhome engine, and suddenly you're running with big block Corvettes. That's life-changing power, literally and figuratively. The racing success of these engines in disguise was remarkable. NHRA stock eliminator racers figured out that a truck 440 in a lightweight A-body could be nearly unbeatable. A 1974 Duster with a motorhome 440 could run 11.50s while still technically being one stocked according to the rulebook. The sanctioning bodies eventually caught on and reclassified these combinations, but not before a lot of trophies went home in the beds of pickup trucks. The international perspective is fascinating too. These engines ended up all over the world. Australian burnout competitors discovered that American motorhome 440s were perfect for their needs: massive torque, indestructible bottom ends, and cheap to replace when you inevitably hurt one. Containers full of motorhome engines were shipped to Australia in the 1990s. Outsmarted safety equipment in vehicles with these swapped engines became an issue. Nobody expected a 1975 pickup to run 12-second quarter miles. Stock brakes, suspensions, and tires weren't designed for that performance. More than a few guys learned the hard way that going fast is easy, stopping is hard. The smart builders upgraded brakes and suspension along with the engine. The comparison with modern engines is sobering. Today's 5.7 Hemi makes 395 horsepower from 345 cubic inches with variable valve timing, sophisticated electronics, and decades of development. A truck 440 with a cam swap made 430 horsepower from 440 cubic inches using 1960s technology. Old-school simplicity had its advantages. Environmental concerns eventually killed these engines. By 1978, even truck emission standards were tightening. The last 443 rolled off the line in August 1978, ending a quiet 6-year run of what might have been Chrysler's best-kept performance secret. After that, it was all 360s and eventual fuel injection. But the formula lived on. Chrysler applied the same philosophy to their 360 truck engines in the 1980s and 1990s. Magnum 360s and Rams got better heads and stronger internals than their passenger car cousins. Once again, a cam swap would wake them up. The pattern repeated. Truck engines built tough for work, transformed into performance engines by those in the know. The philosophical question this raises is profound. What is a performance engine? Is it defined by its intended use or its capability? These truck 440s were never meant to be performance engines, but they had more performance potential than purpose-built muscle car motors. They challenge our assumptions about engineering intent versus engineering capability. The modern collector market has finally recognized these engines. A documented numbers-matching motorhome Ford 40 now brings serious money. Not as much as a six-pack engine, but far more than anyone would have predicted. The guys who hoarded them in the 1980s are sitting on gold mines, and looking back, the truck 440 phenomenon was a perfect storm of circumstances. Strict emissions for cars, but not trucks. Insurance companies focused on marketed performance, not actual capability. Engineers building beyond requirements for durability. Hot rodders willing to experiment, and a camshaft that was the only thing between truck duty and street domination. The deeper lesson here is about hidden potential. How many other overlooked combinations are out there, waiting to be discovered? In an age where everything is computerized and locked down, the truck 440 story reminds us of when performance was limited only by knowledge and imagination, not encryption and lawyers. Today's equivalent might be finding the right tune for a turbocharged four-cylinder or discovering which hybrid system can be hacked for more power. But nothing will match the pure simplicity of pulling an engine from a motorhome, swapping a mechanical camshaft, and instantly having a giant killer. The story ends where it began, with recognition that Chrysler built some of their best engines not for glory, but for work. They didn't advertise it, they didn't brag about it, they just did it because that's what the trucks needed. And in doing so, they accidentally created one of the greatest performance bargains in automotive history. These engines are mostly gone now, scattered into project cars, worn out, or destroyed. But their legend lives on in every forum post asking about casting numbers, every swap meet conversation about motorhome motors, every YouTube video showing another cam swap transformation. They prove that performance isn't about marketing or image. It's about capability, waiting to be unlocked. The next time you see an old Dodge pickup or a vintage Winnebago, take a second look. Under that hood might be hiding one of Chrysler's greatest performance engines, disguised as a workhorse, waiting 4 decades for someone to swap a cam and let it breathe. That's the beautiful secret of the Mopar truck engine. The muscle car era never really ended. It just put on work boots and kept its mouth shut. What's the most overlooked performance engine you've discovered? Drop a comment and share your own story of finding hidden horsepower where nobody expected it. And if you enjoyed this deep dive into Mopar's secret performance history, make sure to subscribe because we're just getting started uncovering Detroit's best-kept engineering secrets.